All right, in the first video, we talked about the Pythagorean theorem. We solved the missing side of a triangle using Pythagorean theorem, and we learned about Pythagorean triples. In this video, we're going to specifically talk about the converse of the Pythagorean theorem. So remember, the Pythagorean theorem states if it's a right triangle, then its two legs squared will add up and equal its hypotenuse square. And remember, our converse is we switch our hypotenuse and our conclusion. So these two will switch. So our converse of the Pythagorean theorem states if a squared plus b squared is equal to c squared, then we know it's a right triangle for sure. So if it satisfies the Pythagorean theorem, then we know it's a right triangle. All right, so let's go ahead and solve a problem. So it says a triangle has side lengths of 85, 84, and 13. Is the triangle a right triangle? And explain. Now, before you do anything, the first thing you should do is check and see, does this actually, or can this actually form a triangle? So remember, we would do 84 plus 13. We take the two small side lengths and we ask ourselves, is it greater than the largest side? So then this will be 97, and that is greater than 85. So we know that it can form a triangle. All right, then we have to then say, is it a right triangle? That means it would satisfy a squared plus b squared is equal to c squared. Now remember, the only letter that matters is the c, or our hypotenuse. That's the only one that matters. But we don't know which one's our hypotenuse in this example. But in order for one of these three to be our hypotenuse, it would have to be the largest number. So if this is going to be a right triangle, then that means that 85 would have to be the hypotenuse. So then we just plug in 13 and 84 for our a and our b squared. So 13 squared plus 84 squared. And then we ask ourselves, does this equal to 85 squared? That's why I'm putting a question mark there to remind us that we need to see, is this equal? And if it is, then we know it's a right triangle. And if it's not, then we know it's not a right triangle. 13 squared is 169. 84 squared is 7,056. And 85 squared is 7,225. Then we will add 169 plus 756, and that will give me 7,225. And since it does equal our c squared, we know yes, this forms a right triangle. And our explanation would be it forms a right triangle because it satisfies our Pythagorean theorem, or the converse of the Pythagorean theorem. All right, so that's applying and using the converse of the Pythagorean theorem. So you could be given three sides and you could be asked to determine, does this form a right triangle? All right, now every single time we do this, it won't equal, because not every single triangle we have is a right triangle. So there will be some cases where it doesn't equal, and we can still determine the type of triangle that we have there. All right, now normally we write a squared plus b squared is equal to c squared. That's the way that we always say our Pythagorean theorems. When we're asked to classify the triangle, I'm going to ask for you to write it c squared and then put question mark a squared plus b squared. I'm going to ask for you to remember it in this order, because if you remember it this order, I think it might be a little bit easier for you to remember these theorems here. So if your c squared, or our hypotenuse squared, is greater than a squared plus b squared, then that triangle is obtuse. If our c squared is less than, then that triangle is acute. Now the reason why I'm saying it might help for you to remember it, thinking of it as c squared first instead of a squared plus b squared, is because we know obtuse is an angle that's greater than 90 degrees. So when we see the greater than sign here, we would just naturally say greater than, well, that's obtuse because it's greater than 90 degrees. And then we know acute is less than 90 degrees. So when we see the less sign written, then we know that it is acute because it's less than the 90 degrees. All right, so writing it in this form allows for you to just naturally want to say or go with how your inequalities are facing. If you do it the other way, which is perfectly fine, I'm fine if you do it the other way, but if you do it this way, you might see this and say, okay, it's greater than c squared, so it's going to be obtuse, but we're always comparing it to our hypotenuse. So this is actually less than, our hypotenuse is less than, so this one would be acute. All right, so I don't really care which way you write it. Just remember that it's always being compared to our hypotenuse. That's the one that we're thinking about. So if our hypotenuse is less than, it's acute. If our hypotenuse is greater than, it's obtuse. All right, so let's go ahead and do a problem with this now. All right, so then we are asked, a triangle has sides 6, 11, and 14. Is it acute, obtuse, or right? So it tells us it's a triangle to begin with, so we don't have to test to see whether or not it can form a triangle, because they're telling us it does. And then, so what we need to do is say, well, which one would be the hypotenuse? So since 14 is the largest, that would be C. So then we're asking ourselves C, and I'm going to put a question mark here. So C squared, A squared plus B squared. I'm not going to put equal to them because we don't know what it's going to be. We're trying to determine one of the three. So this sign can be either less than, greater than, or equal to. So that's why I'm putting a question mark there. And I'm putting that to remind myself that's what I'm looking to solve for. So then it would be 14 squared, and then 6 squared plus 11 squared. 14 squared is 196. 6 squared is 36, and 11 squared is 121. We then add 36 and 121, so we get 196, and 36 plus 121 is 157. So 196 is greater than 157, or our C squared was greater than our A squared plus B squared. So since our hypotenuse was greater, that means that this is an obtuse triangle. All right, that is it for this video, and that's it for this section.